Hello friends, myself Aniket Nikam. Today I would like to discuss the problems based on ER model. Last videos we have learned that how to convert ER model into the tables. So according to the rules we are going to solve the problems. So now very easy problem but very important to understand the concept. Now before this like diagram you can see. So I will understand. So this is what total participation represented by two lines. This is partial participation. This is what identifying relationship. Okay, and it is always associated with weak entity. So this double rectangle represents the weak entity which do not have any primary key. Okay, so now this is discriminator attribute like represented by dotted line. So what is discriminator attribute? What it does, like it represents that it should be combined with the primary key of a strong entity, so that this weak entity get a strong entity. So this weak entity get a primary key. Okay, now this is always this identifying relationship represented by doubly like diamond box. It will be always associated with a weak entity. Okay, now again thing is, okay, now what we have to do, we have to convert this diagram, okay, so into tables. So now we will see the rule. If we have a total participation in a relationship, then we always modify the total participation side table. Okay, so we are going to modify this m table. So this m1 is a primary key, m2, m3, and we will add primary key of this table p1 into the p, as a we are going to add the p1 as a primary key. Okay, now this is what modified table, because this is, here you can get total participation. This is a rule, and this is because total participation is what, all the entity occurrences of m are going to participate in the relationship. Okay, now this is for p, we are going to keep p1 as a primary key, p2 as it is. Now this identifying relationship we are going to add here n1, n2, and p1 we are going to add, because this is what identify relationship, and this is discriminator attribute. So meaning of discriminator attribute means what, it should have a another, it should support, it should take help of another key, it should be combined with another key. Okay, primary key of other table, associated table. Then here in this case we are going to add p1 as a p1 and n1 as a key. So both are keys, primary key here. So p1 n1 is a primary key in this case. Okay, and this n2 is a different attribute. So now in this way, this is a possible minimum possible tables, that is this m table, p table and n table, where we have modified m table, m set table in this case, and we have modified n set table in this case, because this is having total participation, and we kept p as it is. Okay, now the relationship of m and p can be through this p1, because in this case p1 is a foreign key, here m1 is a primary key, in this case p1 n1 is a primary key. Okay, in this way the answer of this question is what, 3. Now if you go for second question asked in gate 2008, now both questions have been asked in gate 2008. Now which of the following is correct attribute set for one of the above tables? So now if we understand, if we clearly decomposed into the, like if you have converted into the tables, then you can get here m1, m2, m3, p1. So we will check the options have which of the combination. We will start with D, m1, p1 we don't have, this is not option. m1, p1, n1 we don't find here. Okay, so this is not option. m1, p1, n1 no. Okay, but m1, m2, m3 and p1 we have. So this is what option. So this is what A option for this you can say question. Okay, so now hope you have understood. So that's why it is very important to understand the rules. Okay, so in my last video you can see I have clearly given all the rules of conversion of ER model into the tables. If you apply that, you can solve all the questions which have been asked related to the conversion of ER into the tables. Okay, so now we will see more 2-3 questions regarding this. Now we will solve this question asked in gate examination. Now gate 2004 or IT, this have been asked. Now we have to solve, see the question. We have given, now this question I have like draw this diagram and I have plotted the attribute, but actually in question they have given the statement in words, they have given all the attributes. So it is like this, E1 has A12, A1, A12, A11, A12 and A13. A11 is a key attribute, A21, A22 and A23, where A2 is a key attribute, and A23 is a multi-valued attribute. Okay, now this is what associative entity. This is a symbol of associative entity, where actually this is looking like a relationship, but in reality this is a entity. Okay, now this is also represents relation. So now E1 and E2 we have. So question have been asked, if you decompose, like if you draw, convert this AR model into the table, then how many numbers of minimum table will be formed, and they should be satisfying the 3NF criteria. Okay, now first, according to rule, we are going to draw the tables. Okay, so now how to convert according to rule? Now first we will start with, let's say E1 is possible, E2 is another possible relation. Okay, now in this case, first thing is 1 to m relationship. So always we try to modify m side table. Okay, now we are going to add modify the m side table, and we are going to add the primary key for this. So the E1 is like this: A11, A12, A1 is primary key, A13. Okay, now in this case we are going to modify m side table, and that will be E21. Okay, so and again A21, this is what A21, A22 and A23. Okay, now A1, A21, A22 and A23. Okay, now A21 is a, understand, A21 is a primary key, and A2 is a multi-valued attribute. Now how to deal with multi-valued attribute? We have to decompose into the table. Okay, and we have to add this key for this A23 model. Okay, and again, if according to the law, we are going to add A11 as a primary key, as a foreign key in this table. Okay, primary key will be A21. Now we have to remove this multi-valued attribute, because see, multi-valued attribute means what? We may have like more than one mobile numbers, we may have multiple addresses. So if we keep the multiple addresses in one table, then it will be causing a problem. Okay, because say that will be again having a data redundancy problem. So now we are going to write a new table, where we will write like A21, we will keep the same primary key of parent table, and that is what a weak entity multi-valued attribute we have to deal with, and we will add here the A23. Okay, so A23 will be multiple addresses. So now A21 is the primary key, let's say customer ID. So customer ID may have multiple addresses. So here customer ID 1 address, let's say A1, customer ID 2 address A2, likewise. So that is what we have decomposed into 3 tables. Okay, now this is E1, E2, and we can give the name as A23 table. Okay, because it is multi-valued attribute. Okay, now we have completed with this, and possible relationship decomposition is what? 3 tables. Okay, so now in this case we are going to have a 3 table decomposition. Now we have to check whether it is in 3NF or not. For this we have to write a you can say we have to understand the functional dependencies. So A11 derives A12 as well as A13. In this table, now A21 derives what? A22, A11 and A23 as well as, okay, so sufficient. So it is deriving all attributes. So now A23 is not here as we have decomposed table. So here A21 again derives A23. Okay, because this is multi-valued attribute we have decomposed. Now if you understand, we don't find any other relationship functional dependency from this table. So only this is key, A11 is a key, and this A1 key is deriving all the attributes, means what? It should be in, because it is in 1NF, understood. Atomic values it is in 2NF because no partial dependency here, because part of key is not determining anything, and it is a transitive it is not transitive dependency because there is no relationship between non-key attributes. Here in this case we don't find any relationship between non-key attributes, because information is not given in the question, and we do not have any relationship between non-key attributes. If they have stated the relationship between non-key attributes, then it would be a transitive dependency. So no PD, no TD. Okay, so no transitive dependency means what? It is in 3NF. Okay, so 3NF is you can say it is verified. BCNF can be also there because it is super key. Okay, now this relation is also in 3NF and BCNF. Okay, and this table also is in 3NF. Okay, it is in BCNF as well as you can say this is in 4NF. Okay, now this way all tables are in 3NF. Okay, decomposition is 3NF decomposition, and that's why the minimum number of tables is answer is 3. Okay, so hope you have understood this question. Now we will see some more questions which you will give the clear picture of applying like ER technique, modeling technique into the tables. Again, this was one of the question asked in GATE 2015. So now the question is actually they have framed in words. I have drawn this diagram. So you can also draw the ER model using by reading the question. It is very easy, and better always you draw this ER diagram because it gives a clear picture. Okay, so whatever is there. So now here E1 is having A11, A12 attribute where A11 is a key, and E2 is having A21 and A22 attribute where A21 is a key as given in a question, and this is having R12 relationship having M to N relationship, and this is R13 having M to 1 to N relationship. Okay, now they have asked the question, same question again, how many minimum number of tables have been formed if we have a relationship should be in 3NF. That is the question. So now it is very easy. Modify n side table, and we will add a primary key of this A1 as a foreign key here for a keeping relationship. When we have many to many relationship, that time we have to create a separate table for this relationship, adding the key primary key of like E1 and primary key of E2. Okay, so now one table will be for of course E1, where we will have the following attributes. So what will be the attributes here? So first attribute will be A11. Okay, now because key, another will be A12. Okay, now that is sufficient. Now we don't have need any attribute because already we are going to create one separate table of, let's say, R12. Now here in this case for keeping relationship we will add here A11, the key of like a primary key of E1 and primary key of E2. Okay, according to rule, because this is M to N relationship. And for now E3 we will have a separate table for E3 of course, because we have to have the data. Then we will have A31 as a primary key and A32. Okay, now the next is we have to modify n side table, and for the keeping relationship we will add the primary key of E1, so that is A11. Okay, this is the primary key we have added as a foreign key in this relation. So both are the, you can say, the keys in this case, or because this is a combination, and here you can understand here both are used as foreign keys and they will be like declared as a keys, and this is, so now minimum number of tables in this case will be, now again we will check. So first for E1, another for E2. So E2 I have like I do not have, so we will draw for E2. So now what is E2? Having the attributes A21 and A22. Okay, so of course basically E1, E2 and E3 we will have tables for all, and we have modified in this case E3 side table because it is 1 to N relationship, so we have modified N side table, and in this case M to N relationship is there, so that's why we are creating separate table for this. Okay, so now minimum number of tables, in this case we have 4 tables. Now our task is to check that whether all are in 3NF or not. So now before that we will have this A11 determining A12. So this is what A11 is the key. So this satisfies, this don't have any partial dependency, this don't have any transitive dependency. It is also, that's why we can say that E1 is in 3NF as well as it is in BCNF. Okay. Now this is also having relationship, so this don't have any problem because this attribute, both are attribute determining itself. Okay, so here no problem in this case because we cannot decompose more and no need to decompose as it is. So this is also not, you can say, having any problem for 3NF. Okay, now if you need in this relationship we can add some more attribute or extra attribute to have a primary key. Okay, but whatever primary key will define, that will be uniquely determining all the attributes because only 2 attributes are here, no more necessary like decomposition. In this case we have A31 as attribute and it is determining all the attributes, so in this case we can say that this is also 3NF decomposition, also BCNF, and in this case also BCNF and 3NF. So in this case the answer comes as a 4. So option where you get value of 4 is the correct answer. Okay, so hope you have understood this type of question, and it is based on whatever I taught you in the ER diagram. Okay, so I would like to discuss on some more questions. Now look at this question. This is asked in GATE 2005 for IT. Okay. Now this is, they have given the question. We have two entities, hotel room as well as person, and this is lodging relationship M to N. Okay. Now the question is, if you wish to store the rent payment made by the to be made by the persons occupying different rooms, then this information should be stored. It should must have, like, it must have appear an attribute of first is person, hotel, room, lodging, or none. Okay. So this is a simple question but tricky question. Now understand, the rent payment can be added to hotel room. Okay. And rent payment can be added to a person. Okay. Now this is M to N relationship. So this type of conversion, what we do, we are going to create how many tables? 3 tables, because the relationship is M to N. Now first is, we will have this separate table for hotel, where we will have add attribute of hotel. Second, we will have for lodging. Okay, because this is what 1 to N relationship, and we will add for person. Okay. Now this is rent payment can be attribute of hotel room, but it become redundant. Let's say hotel room are having, let's say I'm having 2 3 4 number 4 3 hotel rooms, and let's say I'm having, like, this is hotel room, payment is, let's say 2000, 3000, or 1000. This will be the payment rate. Now let's say customer ID comes, and he adds, like, here first number of a customer. Now it is like living in a room 2, so he will have a payment of 2000. Okay. Now again, suppose a customer B comes, and he again takes the room number 2 in some other period, then we will have to add here again B, and again room number 2 2000. Means what, the data is becoming more redundant. Okay, so this is not good practice to add in a hotel room, because if we add, because many customers are coming in a hotel room, so it is not good relationship, because again relationship is many to many. In person, if you add, we can add in a person, but thing is again, this becomes again redundancy, because here one person can go into more hotels. Okay, he can go to the, can book more rooms and different rooms. Similarly, one hotel room may have different person. So similarly, the best option is, this is lodging attribute, lodging relationship. So we have going to create special table for M to N. So better we will add in a lodging. Okay, so I will add here M to N. So I will add here rent to be paid by. So the answer is person, hotel room, or lodging. So this can be a attribute of a lodging. Okay, so it is the best practice, because this is M to N relationship. Now look at this question. This is asked in GATE 2017. This is also a very interesting question. Question read: an ER model consists of a database having A and B two entities, and this is having relationship R, which don't have its own attribute. Under the which of the following condition we can say that can the relation table for R be merged with that of A? So now this is when we have many to many relationship, that time we create a separate table for R. Now they are asking where we can modify the A side table. So the condition for modifying A side table is, first is it should be a many side, and second is total participation. Now in this first option we will check. So they have given in the words, I have written a diagram for understanding purpose. Now this is what total participation, one to many relationship. So now many relationship is side of B. So now in this case there we can modify either, let's understand, we can modify B side table, or we can modify A side table, because here one to many, and as well as it is total participation. So here ambiguity arises, so this is not option. B option, this is a partial participation and this is many sides. So this time we are going to modify the B table, okay, B entity, and we will add attribute of A if it has, okay, and we will add a primary key of our A in this side table. Now C option is this is having total participation, so as well as many sides. So that time, this time we can modify this A entity, and we can merge R with this, and we will add the primary key of B into this table as a foreign key. So this is the correct option. And D, because here M side table we can modify A side table, but again having partial participation, so this giving the ambiguity. Okay, so now this is a C option is having, so now possible options can be a D also, because it is having many to one relationship, but the best answer which gives the 100% accuracy, that is C option, because having total participation as well as many relationship. Okay, if this option is absent, that time we can pick up A option, because having many to one relationship. So always we are going to modify many side relationship. So this is the first priority, this will be the second priority, and this is third, because but this is having ambiguity, because one side you have M and this is having one side total participation, so you can do anything. Okay, so this is not predictable, so the best option for this question is answer C. Okay, so let's like, if you have understanding the concept, please go through the steps, revise the steps, and because many times, like after 3-4 years they have asked the questions for ER diagram. Not every year they are asking questions for ER diagram, but like other examinations also I have seen the questions from ER modeling. Okay, now look at this question. They are asking that identifying the incorrect statement. The first is an attribute of entity can have more than one value. Okay, second is an attribute of entity can be a composite. Okay, so this is like you have to think for. C option is in a row of relational table, an attribute can have more than one value, and D, in a row of relational table, an attribute can have exactly one ordinal value. So we have to identify incorrect statement. Attribute of entity can have more than one value. So what do you think? Can attribute have entity more than one value? Yes, that is what many of the student will confuse with this statement. They will think that attribute should have one value, but it is not. Attribute can have more than one value, and that is, we can see, we can talk we can like write this as a multi-valued attribute. Okay, so this is multi-valued attribute where more than one value is there, so this is true statement. Another is an attribute of entity can be a composite. So many times we can have a composite attribute. Okay, let's say we can define a composite primary key. Okay, so we can have composite attribute. Now this is also true. See, in a row of relational table, an attribute can have more than one value. Okay, so where this violates the 1NF, because an attribute in row of relational table, attribute do not have more than one value. Okay, because in a more rows we can have, but in one row we cannot have. Okay, if it is having in one row means what? It is having in one cell more than one value, so it is like it is denying the property of 1NF, so it will not be in 1NF. So this statement is wrong. And D is, in a row of relational table, an attribute can have exactly one ordinal value. That is true. Okay, so the correct option is option C. So thank you very much. I would like to discuss more on the ER, but I think the problems I have taken are sufficient for solving the more problems you are going to face in NIC as well as GATE examinations. So all the best for your examination. Thank you very much for watching the video.